So this is just a quick zero production value update on my Atari 8-bit Wi-Fi project that I'm working on. This is a PBI based Wi-Fi interface instead of a SIO. So I've got a prototype that I've kind of got put together here, and I'm eventually going to take this to a PC board design, but I'm working out all the design issues with hand-wired prototype here. Got a baseboard that's plugged into the PBI on the back of the Atari. The first board in the stack here is an Altera Max 10 FPGA evaluation board. That has a couple of Arduino headers on it, so you can use standard Arduino boards with it. I just have a blank Arduino prototyping board in there. And then on top of that, I have a Espressif ESP32. This is actually one from SparkFun. They come in different form factors, usually little metal cans, but this is an easy one to prototype with. Some other chips on the same board here. This is all level conversion because the FPGA is 3.3 volt and the Atari is all old school 5 volt. And then this chip over here is actually a programmable PLL chip. I'm taking one of the clock signals inside of the Atari and multiplying it by 32 basically to have a high-speed synchronized clock that I can drive internal logic in the FPGA. And the whole point of that FPGA basically is to act as an interface between the Atari 8-bit bus and a SPI bus that's on the ESP part. That controller doesn't really have any parallel buses. It's a much more modern processor, but it does have capability to talk over a SPI bus at up to like 80 megahertz, so it can be very fast even though it's a serial interface. So I've written a bunch of custom logic that lives inside of the FPGA that essentially takes SPI on one side, Atari parallel bus on the other side, and acts as a mediator between those two. There is a big chunk of dual port RAM that I'm using inside of the Altera FPGA, and basically the Atari and the ESP can fill up and read out of those chunks of memory, and then there's some registers and some other logic that kind of help with handshaking back and forth. So that's that side of it. There's a bunch of test stuff I've got hooked up to it because I've been working pretty hard on it the last couple days, and now finally have data flowing between the two. But if we look over here, I've got the Atari booted up. This 8-bit does have a ultimate 1 megabyte in it, just very convenient for development. So we're going to boot it up, and it should come up in Spartados. Takes a moment to get through some timeouts. Alright, and in this directory, I've got a test program that I've written. Now, this is being served up over a, it's kind of hard to see here under this pod. That thing is a SIO to USB, basically. It's just a USB to serial converter. And I've got Respect running over here in this window. So I've got a C compiler, cross compiler for the 6502 running in a Linux VM. I basically write my test code. It produces a executable output file, and I have Respect, which is a disk emulator, pointed to the directory that stuff gets output. So it's a very nice quick cycle. I can make a change to my code, build it, and essentially it immediately shows up on the Atari and I can run it. So we're going to run the test code that I've been working on this weekend, which is just called PBI to SPI. This is just a test for this interface going between the ESP and the Atari. So up on the screen, see there's a divided up into a couple buffers. The top section here is 256 bytes. That's a chunk of RAM for the ESP to write to the Atari, and the bottom is a chunk, same size, 256 bytes, for the Atari to write back to the ESP. Those are actually banked. There's, forgot how many, I think 64 banks of each of those, so there's a total of 16 kilobytes in each direction that can be written and then the Atari can bank switch it around and look at it and manipulate it to its heart content once it's been received on that side. And the ESP can do the same. It can read and manipulate those two memories. But you see they're just sitting there currently. They're actually holding some state from the last test that I ran. So back over here on the workstation, I'm back in the window now. This is where I'm writing code for the ESP. This is also being written in C. There's a tool chain and compiler and everything for that. What I'm going to do now is basically build that code and then flash it onto the ESP microcontroller, and then it'll run a console monitor basically, so you can see debug output coming out of the ESP. So it's building, now it's downloading. It takes a moment. So it's downloaded, and now it's up and running, and it's actually blasting data over the SPI bus and into the FPGA essentially. And now you can see over here on the Atari that there's all kinds of crazy stuff going on. So what's really going on here is that the ESP is basically writing a buffer's worth of data. In this case, I'm just writing a single bank, so 256 bytes. The ESP is filling in this little iterator field just so you can see something changing, and then it's just filling in test bytes into the rest of that buffer. It then does a SPI transfer over into the memory in the FPGA, and a register gets set so that the Atari says, hey, there's some new data that shows up. The Atari code is pretty simple right now. All it's doing is noticing that some bytes have shown up, copying them to the screen, and I've had to do some, this is C, and not a particularly efficient compiler from what I can tell, but I did some hacks to just copy this data right to the screen buffer, so it goes a lot faster. But what it also then does is copy that packet that it received into the slave buffer, and then signals the FPGA that, hey, there's data waiting on the other side, so that the same packet basically gets generated by the ESP. The Atari sees it, copies it over to its buffer going the other direction, and then it gets sent back to the ESP, and then it sees its buffer. So all this crazy stuff spooling out over here is basically the other side of that transfer. Doesn't look like much right now, but this is really the basis for all of the actual network communication and other things that I intend to do with this project later on. This is the pump that basically moves the data between these two processors. So that's really that. This pile of craziness here is actually starting to show some signs of life. It's just a data pump right now, moving some bytes back and forth, but with a little bit more work on the structure of that in the FPGA, and getting some more sophisticated test code written on both the ESP side and on the Atari side, I'm not that far away from actually being able to start moving network data. So I have to build a protocol basically on top of this low-level hardware interface that will then allow the Atari to control the ESP. So it's going to have to do things like configure its Wi-Fi settings, and then I think what I'm going to do is build out something that's like a Berkeley socket style interface that works over this connection, so that the entire TCP/IP stack is going to stay running in the ESP. I don't see the sense in actually burdening the Atari with that. It would be possible, but I just don't see the point. I would rather do a more high-level interface to the Atari so that it'll be easier to build more useful applications. Download a XEX file and run it on the Atari, send data to a printer, lots of possibilities here. Really the core functionality of the thing I want to get working though, and part of its name is in the PBI RFI thing, is that I want a very basic telnet style interface to work with an actual R device handler, so that you can use an old school terminal program and actually telnet into a modern, modern with quotes, modern Atari BBS. But there's all kinds of things that I have ideas for on this project. So we'll see how it goes. Thanks a lot, and stay tuned.